In this video, we're going to go over some practice problems from sections R.2, R.4, and 1.1 from our textbook. Now, before attempting these practice problems, make sure that you review the lecture videos on each of these sections that are provided by Pearson. You can find those lecture videos at the beginning of each homework assignment. So those lecture videos as well as these practice problems will help to prepare you for the homework assignments as well as the exams. So we just have a list of a bunch of questions from each section of our textbook, and all of these problems can be found in the textbook. So we're going to start with question 4 from section R.2 here. We're given this set here, and this is read as m, such that m is a natural number that is less than 9. And so what we want to do for this question is list the elements in this set. So we know that the natural numbers are going to be all positive numbers greater than 0. So 1, 2, 3, all the way up to infinity. So if we want to list the natural numbers that are less than 9, we'll start with 1, 2, 3, all the way up to 8, because these are all the natural numbers that are less than 9. All right, so similarly for question 5 here, we have this set, and it's read as z such that z is an integer greater than 4. So now we're looking at the set of integers that are greater than 4, and so the integers are all whole numbers from negative infinity up to positive infinity. So if z is an integer that is greater than 4, we're going to start with 5, since 5 is greater than 4, up to 6, 7, 8. These are all numbers that are greater than 4, and this is actually going to continue on forever. Now, for question 4 here, this is an example of a finite set. We have a countable amount of elements in our set. In question 5 here, this is what's called an infinite set because this continues on forever. All right, let's move on to questions 15 and 18 here from this section. Now, in this case, we want to use set builder notation to describe each of these sets here. So, essentially what we're doing is now we're given a list of elements in a set, and we want to give that in set builder notation. In question 4 and 5, we were given a set in set builder notation and then had to list the elements in each set. So we're doing pretty much the opposite here. So we have the set which contains the elements 2, 4, 6, and 8. So in set builder notation, I'm going to use the variable x. So we have x such that x needs to be something that describes what we see here. Now notice that all of these integers here are even, and they are between 1 and 9. So what we can do is list exactly that. We can say x such that x is an even integer between 1 and 9. So that's how we can use set builder notation to describe this set. Now, something to note here is that all we're doing here, like I said, is using set builder notation to describe the set. So there's not one right answer. There actually, in some cases, could be several correct answers. As long as it describes the set, we're good to go. So another example for this one, we're still going to use this x here. So we have this variable x such that we could say that x is an even natural number less than 9. So this also describes our set here because we know our natural numbers are going to be numbers 1 through infinity. So all positive numbers not including 0. And if we say even natural numbers, that's exactly what these are. And then we're limiting this set to be numbers that are less than 9. So that exactly describes this set here. Now for question 18, we're going to do something similar. In this case here, it looks like this is going to be an infinite set. It continues on in both the positive and the negative direction. So here, using our set builder notation, we're going to use our variable x again. And we can use any variables. We could also, for the sake of that, we can use any variable. We could use a. such that we want to describe this set here. Now notice, like I said, this is going to be an infinite set continuing in both our positive and negative direction, and notice that these numbers are also all multiples of 3. So we can use that to describe this set here. So we're going to use our variable a. So we have a such that a is what we'll call an integer multiple of 3. Remember, our integers are numbers from negative infinity to positive infinity, not including decimals. So we can use that to describe the numbers in this set, and it'll be an integer multiple of 3. All right, let's move on to 37 and 40 here. In this case, we just want to give the additive inverse of each number. This one's pretty simple. The additive inverse in this case is just going to be the opposite. So the opposite of 6 is going to be negative 6. The opposite of negative 14 is going to be 14. Okay, so not too bad. Now let's look at some problems involving absolute value. So looking at 49 here, we want to evaluate this. We have minus the absolute value of a negative 2. So what we're going to look at, we're going to keep this minus out front and then just look at what's happening inside of our absolute value. We have the absolute value of negative 2, so that's going to give us a positive 2. And then we have a negative on the outside, so our final answer here is going to be negative 2. All right, looking at 53 now, we have the absolute value of negative 2, which we know is going to be positive 2. And then the absolute value of positive 3. Well, that's still just going to be positive 3. What the absolute value does here is it's going to make whatever is inside of our absolute value positive. All right, and so this will just be 5. Now lastly, for question 56 here, we still have this minus out front of our absolute value, just like we saw in question 49. And then on the inside of our absolute value, we have 6 minus 12. So I'm going to keep our absolute value sign here. 6 minus 12 is going to be negative 6. Now we have this negative on the outside here, and we know that the absolute value here is going to make this guy positive. So we're going to have negative 6 here. Now I'm just putting the parentheses here just to emphasize what's happening, that the absolute value is making this negative a positive. All right, now we're going to finish up section R.2 with some inequalities here. What we want to do is we want to use an inequality symbol to write each statement. So for question 81 here, we have that 7 is greater than negative 1. So we're just going to use our inequality symbol. We know that 7 is going to be greater than negative 1. The inequality symbol that we used in this case is the greater than symbol here. Now just a reminder, when we're using our inequality symbols in either case, we can kind of think of this as an arrow that's pointing to the smaller number. All right, let's do question 82 now. We have negative 4 is less than 10. So negative 4. And then our inequality symbol is going to be pointing to the smaller number. So less than 10. All right, the inequality symbol we used in that case was our less than symbol. Now for 83 here, we have 5 is greater than or equal to 5. Now if you notice for all of these, we're writing them left to right in the same way that we would read them. So if we're starting with 5 is greater than or equal to 5, the first thing we're going to have here is 5, and then we're going to have our greater than or equal to symbol, and then 5. Now our greater than or equal symbol looks like this here. We have a greater than sign, and then we just have a line under it. Now this indicates that 5 is greater than, or it can be equal to 5, and that is a true statement. All right, and then lastly, for question 88 here, we have 13 is not equal to negative 13. So we start with that, 13, and we use our not equal symbol to negative 13. And so in the last two cases, this is our inequality symbol, and this is our inequality symbol. All right, so now we're moving on to section R.4 here. We're going to start with using exponents. So for question 12 here, we have 8 times 8 times 8. So this is 8 times itself 3 times. and we can write this with exponents as 8 cubed. It's 8 times itself 3 times. Now for question 13 here, we have 3 over 4 times itself, and we have that 5 times. So we can just write this as 3 over 4 to the 5th power. Alrighty, let's move on to these questions here. Now what we want to do is evaluate these exponential expressions. So here we have 1 over 5 cubed. So this is going to be 1 over 5 times itself 3 times. So this will be 1 over 5 times 1 over 5 times 1 over 5. So not too bad. When we're multiplying fractions like this, we know that we're going to multiply the top. So we have 1 times 1 times 1, so that'll just be 1 on the top. And on the bottom, we're going to multiply these guys as well. We have 5 times 5 times 5, so that'll be 5 cubed, and that'll be equal to 125. All right, now for question 31 here, this one's a little trickier. We have negative 5 cubed. So this is going to be negative 5 times itself 3 times. And we're going to take this negative with us when we're cubing it because it's inside of these parentheses. So that guy's got to come with us. So this is going to be negative 5 times negative 5 times negative 5. So this is going to be, notice we have 5 times 5 times 5, which we know is going to be 125 from the previous question. However, we have a negative times a negative, which will make this here, this product, positive. So this will be negative 5 times negative 5 will give us positive 25. Then we're multiplying that again by another negative 5. So this tells us that our final answer is going to be negative. Because we have, like I said, this product will be positive 25. Then we're multiplying a positive number by a negative, which will be a negative number. So this will be negative 125. Next, for question 36 here, we have a negative 3 cubed. Now in this case, notice we don't have any parentheses like we did on the last one. So in this case, this negative sign is not going to come with us when we're cubing this 3. This negative sign is going to stay on the outside, and what we're cubing is just 3. In the last example, we were cubing the negative 5. Here, we're just cubing the 3 since there's no parenthesis. Alright, so this negative is going to stay on the outside, and we know that 3 times 3 is going to be 9. If we multiply that by another 3, that'll be 27. So our final answer will be minus 27. Alright, so with that, we're going to move on to square roots. So for question 43 here, we want to take the square root of 169. So what we can do is just plug this into our calculator. The square root of 169 is going to be 13. But we know that this is the case because 13 squared, or 13 times 13, is equal to 169. So if we want to take the square root of this number, we'll get 13. Alright, let's look at the next question here. We have the square root of 100 over 121. So what's happening with what this is our radical symbol here is that we're taking the square root of this whole thing. So we can apply this square root to the top and bottom of this fraction separately. Now the square root of 100 is going to be 10 by the same reasoning here. 10 times 10 is going to be 100. So that means the square root of 100 must be 10. And similarly, the square root of 121 is going to be 11 because 11 times 11 is 121. Alright, and lastly, for question 50 here, we have minus the square root of 64. Now notice this minus is not under our radical symbol here, so that guy's just on the outside. And what we'll do is evaluate the square root of 64, which is going to be 8. So our final answer here will just be minus 8. Now something to note here is that if the minus sign were under this radical, we would actually not be able to evaluate this yet. This will not be a real number. So if you run into that in the homework, you would just respond that this is not a real number, or however the format is for Pearson. They'll let you know in the homework question. All right, now Let's move on to simplifying some expressions. So in this case, what we're going to do is use our order of operations, and something that can help us remember that is PEMDAS. Now this stands for parentheses, exponents, multiplication, division, addition, and then subtraction. So we're always going to do parentheses and exponents first, and then multiplication and division second, and this will depend on the order from left to right. So for example, we'll see in question 59 here, we have a multiplication and a division here, and we'll do it in the order that it occurs from left to right. So we'll do this multiplication first. And similarly for addition and subtraction, whichever comes first from left to right. All right. So for question 59 here, like I said, doing PEMDAS, we don't have any parentheses or exponents, so we're good there. The next thing is multiplication and division, whichever comes first. The first thing that we see is this multiplication here, the 6 times 3. So we'll do that first. 6 times 3 is going to give us 18. Now next we do have subtraction here, but remember multiplication and division is going to come before subtraction. And we do have a division here. So the next thing that we're going to do is this division. So I'm going to have 18 minus whatever this division is. This division, we have 12 divided by 4 is going to be 3. So we got that from the division, and we got 18 from our multiplication here. And then it becomes pretty simple. 18 minus 3 is going to be 15. All right. Let's do question 73. This one's a little more complicated. Now we do have parentheses and exponents. So first thing we have here is this exponent, and then we have this parenthesis here. So we're going to have to work with those guys first. What I'll do here is I'll just keep this 18 out in front. We're not doing anything with that yet. But what we are going to do is subtract out 4 squared, which we know is going to be 16. So that's how we got this guy here from our 4 squared. We're not going to do anything with our plus 5 yet, because the next thing we need to do is work with our parentheses. Now within our parentheses, we have 3 minus 7, and this will give us a negative 4. And so I'm just keeping the parentheses here because we're dealing with a minus negative 4, just to emphasize that step. Now, all we really have here is just addition and subtraction. So although in PEMDAS, like I said, we have this addition before subtraction, we're really just going to do it in the order that it occurs from left to right. So we can do this 18 minus 16 first. 18 minus 16 gives us 2. Then we have this plus 5. And then here, we have a minus negative 4. This minus and this negative here undo each other, so this becomes a positive 4. Now 2 plus 5 plus 4 gives us 11, and that is our final answer. All right, now let's do 70 and 79 here. Now in this case, we don't have any parentheses, but what we do have are these absolute value symbols here. Now we also are going to treat absolute value symbols as grouping symbols, so we do want to evaluate this before anything else. So first thing we're going to do is work with what's inside our absolute value. So we're going to leave our negative 4 on the outside. Then we're going to take the absolute value of 2 minus 4, so that'll be the absolute value of a negative 2. Then we're still going to add 8 times 2 on the outside here. Now, this negative 4 will stay here, and then evaluating the absolute value of negative 2 gives us a positive 2. Then we still have this plus 8 times 2 here. Now, just like when we have a number on the outside of our parentheses here, we are multiplying it. Same thing with our absolute value, our grouping symbols here. This is negative 4 times the absolute value of 2 minus 4. So we'll get negative 4 times 2. This will be negative 8 plus 8 times 2, which will be 16. So this will give us positive 8. All right. Now for question 79 here, this is a little more complicated. We do have exponential expressions, or exponential terms. We do have our grouping here, our parentheses here, and then we also have this division bar. Now we can also think of this division bar as a grouping symbol. meaning what we're going to do first is everything in the numerator, the top of this bar, then everything in the denominator separately. So we're going to do PEMDAS on everything up here. The first thing that we're going to evaluate is going to be what's inside our parentheses here. Now we can also think of this square root here as an exponential term, so we are going to have to evaluate this first before we can figure out what's inside the parentheses. So what I mean is we have -5 plus the square root of 4. The square root of 4 is just going to be 2. So inside our parentheses we have -5 plus 2. Now we can also, in the same step, evaluate this here. This is our exponential term. We have -2 squared. And remember, since we don't have a parenthesis around this minus, we're just going to take this 2 squared here. The minus will stay on the outside. So 2 squared is going to be 4. Then what we're going to do is PEMDAS on the denominator. So here we have this -8 plus our exponential term, 3 squared, well, that'll be 9, and then -1. So just to emphasize, here we took the square root of this guy. We got 2. We did 2 squared, we got 4 here. Get another color. We did 3 squared, we got 9 here. So that's all we did in that step. Now, we're going to do what's inside the parentheses. We have -5 plus 2, so this will give us -3. Still have -4 on the top, and on the bottom, we have -8 plus 9 minus 1. So this actually gives us 0. And remember, we can never ever divide by 0. So this one actually is just going to be undefined. So if you ever run into a problem where we are dividing by 0, it'll just be undefined. All right, and the last 2 questions for this section here, what we want to do is we're given this expression, and then we're given values for our variables in these expressions. So all we need to do in this case is evaluate by plugging in the values for these variables. So for 83 here, we have 3a, and we know that a is going to be equal to -3, and we're adding the square root of b, and we're given that b is going to be equal to 64. So let's plug in that information. We have 3 times a, and we know a is going to be -3. And then we're adding the square root of b, and we know b is 64. So just plugging in these values. All right. We know that 3 times -3 is going to be -9, and the square root of 64 is 8. So in this case, this will just be -1. All right. Now similarly for 87 here, we have 4a cubed, where a is -3, and in this case we don't have a value for b, but we don't have a b in this expression, but we do have a variable c, and that's going to be equal to 6. So plugging this information in, we have 4 times -3 cubed plus 2 times 6. Now we want to be careful with this here. We're plugging in -3 for a, and here we have a cubed, so all of a is going to be cubed, and all of a is -3. So we're going to have 4 times -3 cubed, which will be -27, plus, we can do this multiplication also, 12. So 4 times -27 is going to be -108, and then we're adding 12 to that guy. So our final answer here will be -96. All right, so we're going to finish up this video with section 1.1 from our textbook, and we're going to start with question 9 and 12 here. What we want to do is determine whether each of the following is an expression or an equation. Now this is fairly easy. In order to determine that, we just want to figure out if either has an equal sign. For question 9 here, this one does have an equal sign, so this tells us that this guy is an equation. The rule of thumb is equal sign means equation. Now for question 12 here, notice that there is no equal sign, so this guy is just going to be an algebraic expression. Alright, so that's it for that. As long as there's an equal sign, it is an equation. Now, I will be referring to, whenever we have an equation, the left hand and right hand side of the equation, and all that means is that we're looking at the left side of our equal sign or the right side of our equal sign. Now let's move on to these questions here. In this case, what we want to do is solve each equation and check the solution. And it looks like I did not give myself enough room to check the solution, but we will attempt to do that for at least one of these. So we're going to start with solving this equation here for question 19. So when we're solving an equation, what we want to do is isolate the variable in the equation and determine its value. This is because what we want to figure out is the value which makes the left-hand side of our equation equal to the right-hand side of our equation, which makes it a true statement. So in order to isolate this guy and determine its value, what we're going to do is essentially the order of operations in reverse. What's happening to this variable here is it's being multiplied by 7, and then we're adding 8 to that. So in order to get this guy alone, we're going to first have to undo this last operation, and then this first one. So in order to undo the operation of adding 8 to these guys, we're just going to subtract 8. And whatever we do to one side of the equation, we have to do to the other side of the equation to balance it out, to make sure that we still end up with the correct solution. So we have plus 8 minus 8 here. These guys will cancel. And then we're left with just 7x on the left-hand side of our equation. Now on the right-hand side of our equation, we have 1 minus 8. This will give us negative 7. And then we know that what's happening to this variable now is it's just being multiplied by 7. So we're going to want to undo that multiplication. In order to undo multiplication, we just divide it. We use division here. And we know that 7 divided by 7 is just 1. So these guys cancel here. And then whatever we do to one side, we have to do to the other side of our equation. So we're just left with x by itself, and that'll be equal to negative 7 divided by 7, which is just negative 1. Now for this one, I'll check the solution here, and all that means is we're just going to plug in the value that we got for x. So x is equal to negative 1 here. What we're going to do is plug it into our equation. So we have 7 times negative 1 plus 8 is equal to 1. And what we want to do is make sure that this is true. This left-hand side does in fact equal 1. So we have 7 times negative 1, which is negative 7, and then we're adding 8 to that guy. Now notice negative 7 plus 8 does equal 1, so we're left with 1 is equal to 1. So it looks like that is a solution. Now, what this tells us is that our what's called our solution set, we can write like this here, is going to be negative 1. So our solution set is just a set of potential solutions for this equation. We will see in later sections that we can have more than one solution for an equation. All right, let's do question 22 now. In this case here, we have 9x plus 1 is equal to 7x minus 9. So in this case here, what we're going to utilize is combining like terms. So as you should know, terms are called like terms if they have the same variable raised to the same power. So 9x and 7x here are like terms because they both have x raised to the first power. If we had, for example, let's say 9x and 7x squared, these guys are not like terms because although they do have the same variable x here, it's not raised to the same power. In this case, we have it raised to the first power, and in this case, it's raised to the second power, so we would not be able to combine these guys. Now, by the same logic, this plus 1 and this minus 9 here are also like terms because they have the same variable raised to the same power because they don't have a variable. So what we want to do is combine our 9x, our 7x, and our plus 1 and our minus 9. Now, we can't just combine them as they are because in order to do that, we need to make sure that these like terms are on the same side of the equation. Our 9x is on the left-hand side and our 7x is on the right-hand side. So in order to get this 7x to the left-hand side of our equation so we can combine it, we can move it over. Now we can move it over by just subtracting 7x to both sides of our equation. These guys cancel here. Then we're left with 9x minus 7x. We still have this plus 1 here, and that'll just be equal to minus 9 left on the right-hand side of our equation. All right, now we can combine our 9x and our minus 7x. This will just be 2x. We have 9 x's, and then we took away 7 of them, so we have 2 remaining. We still have this plus 1 here, and that's going to be equal to minus 9. Now, to do the same thing here, combine our constant terms here, our 1 and our minus 9. We can just subtract 1 from both sides of our equation. We can move it over. We're left with 2x is going to be equal to minus 9 minus 1. So, this will be 2x is equal to minus 10. And then lastly, to completely solve and get x alone, we're going to undo this operation. It's being multiplied by 2. So we're going to divide by 2 on both sides. That cancels, and what we're left with is just x on the left-hand side of our equation. And we have negative 10 divided by 2, which is just going to be negative 5. So that will be our solution. And then I don't have enough space to check the solution, but what you do in this case is plug in this negative 5 into both of our x values here. Make sure that this left-hand side is equal to this right-hand side. All right, let's move on to question 28 here. Now in this case, what we're going to have to use is the distributive property in order to solve this guy. So what's happening here is we have this 2 is being multiplied by what's inside our parentheses here. Now, normally, if we were just dealing with numbers, we would simplify what's happening inside of our parentheses using our PEMDAS, and then just multiply this 2 to this guy. But notice we don't have like terms here. We have a 3 and a minus 2x, so we can't combine these. So what we're going to do is use our distributive property and distribute this 2 to both terms inside of our parentheses. So we're left with, we have 2 times 3, and then we have minus 2 times 2x. And then on the right-hand side of our equation, we still have this x minus 4. So this guy is just multiplying, so we have 2 times 3 here, and multiplying this guy. 2 times minus 2x, this minus is just up front. Alright, so this leaves us with 6 minus 4x on the left-hand side. And now this just becomes an equation very similar to question 22 here. We're just going to combine like terms, and we're going to do so by moving the terms to the same sides of our equation. So I'm going to add 4 to both sides of our equation here. This guy cancels, and I'm just left with 6 on the left-hand side. Now on the right side here, I'm going to combine like terms. I have this x plus this 4x, so we'll combine these guys. So I have 6 is going to be equal to 5x. I have 1x, and I'm adding 4 more x's to that. That gives me 5x. And I still have this minus 4 here. Now 6 and minus 4 are also like terms, so I'm going to move them to the same side. I have 6 plus 4 on the left-hand side of my equation. That'll be 10 is going to be equal to just 5x. This minus 4 and this plus 4 canceled. Now lastly, to get x completely alone, we're going to divide both sides by 5. So I'll get 2 is equal to x. And you can also write that as x is equal to 2. You can write it in either order. Usually in math, we do like to write it as this here, but either one's okay. All right. Now the last one here is a little more complicated, but we're just going to do the same thing. We're going to use our distributive property in 2 places, and then combine like terms and get our x variable completely alone. So the first thing we need to do is distribute this 4 to both terms in the parentheses here, and then this 2 to both terms in the parentheses here. So this will be 4 times x, so we get 4x, minus 2 times 4, which is going to be 8, plus 2 times x, so we get 2x, plus 2 times 3, which is 6. And then we have that's equal to 6 on the right-hand side. Now we can combine terms combine like terms right away because we have a 4x and a 2x on the same side of our equation and a -8 and a +6 on the same side as well. So we have 4x plus 2x, so this will be 6x, and then we have -8 plus 6, so this will be -2. And on the right hand side, we still have that this is equal to 6. Alright, now we want to solve for our variable x, so we're going to undo everything that's happening to it here. So to undo this -2, we're going to add 2 to both sides of our equation. So we have 6x is going to be equal to 8, and then to get x completely alone, we'll divide by 6 on both sides. We'll get x is equal to 8 over 6, and then we can simplify this fraction. 8 and 6 both share a factor of 2. So if we divide both by 2, we will have simplified this fraction to get our final answer of 4/3. All right, let's move on to our last two questions here. Now in this case, we're working with fractions. So for question 57, I'm gonna show you two different ways to do it. So we have 6 over 5x is equal to -1. So again, we want to solve this equation here. So we want to isolate our variable x. And what's happening to this is it's being multiplied by 6 over 5. Or we can think of it being multiplied by 6 and divided by 5. So what we can do in this case is we can multiply both sides of our equation by 5. What happens is it undoes this here. 5 divided by 5 is just going to be 1, so we're just left with 6x on the left-hand side of our equation. Now on the right-hand side, we have -1 times 5, so this will be -5. And then lastly, to get x completely alone, we're just going to divide both sides by 6. This cancels here, since 6 divided by 6 is just 1. And so on the left-hand side, we're left with x. We got x by itself, and that's going to be equal to -5 over 6. So this is one way we could do this problem. Another way to do this problem is, like I said, to just think of this as being multiplied, as x being multiplied by 6 over 5. Now what we could do is, in one fell swoop, we can get x alone by multiplying it by the reciprocal of this guy. Now the reciprocal of a fraction we can get by just reversing the numerator and the denominator. So this reciprocal of 6 over 5 would just be 5 over 6. So if we multiply this by 5 over 6 here, what happens is we have 5 over 5 here, that cancels, and then we also have 6 over 6 here, that cancels. So on the right-hand side of our equation, we have to multiply that by 5 over 6. And so on the left-hand side, we have x completely alone in just one step, and we get that that's going to be equal to -5 over 6. So we get the same answer. You can do whatever approach you're more comfortable with. This one is a little bit easier. We're just working with one step, or you can do it in two different steps like this. Now, the last question here involves two fairly complicated fractions here. Now, what's happening here is we are adding them, and we should all be familiar with the fact that if we want to add two fractions, they need to have the same denominator before doing so. And so, using that idea here, what we want to do is we want to find the least common denominator for these two numbers, and then what we're going to do is actually multiply both sides of our equation by that least common denominator. Now, if it's not obvious to you, that's okay. We can find the least common denominator of these two numbers 4 and 6 here by just listing out their multiples. So the multiples of 4 are going to be 4, 8, 12, 16, 24, and so on. And multiples of 6 are going to be 6, 12, 18, 24, and so on. So the least common denominator is going to be the smallest multiple that these guys have in common. And just looking at that, we can see that that's going to be 12. So the least common denominator for 4 and 6 is going to be 12. So if we wanted to add these guys, what we would do then is multiply the top and bottom of this fraction by 3, because we would get 12 in the denominator. And then on this side, we'd multiply the top and the bottom by 2 because then we'd get 12 in the denominator, and then we could add these. Now we can solve this equation that way and then combine like terms in the numerator and then deal with the denominator in the end. But what we're going to do in this problem is multiply both sides of our equation, like I said, by this least common denominator right away. And it actually simplifies this question right off the bat. So we have 3x minus 1 over 4 plus x plus 3 over 6, and that's going to be equal to 3. So we're going to multiply both sides of our equation by 12, our least common denominator that we found. And remember, when we're multiplying both sides of our equation by something, or doing anything to both sides of our equation, if we have two separate terms like this, we're going to have to do it to both of these terms. We can think of it as multiplying this entire thing by 12, or just multiplying it by 12 separately, like this here. All right, so now what we get here is we have 12 times 3x minus 1 over 4 in this term, and then 12 times x plus 3 over 6 for this term. And then on our right-hand side, we just have 3 times 12, which is 36. Now notice, here we have 12 divided by 4, so we can simplify that right away. This is just going to be 3 times 3x minus 1, doing 12 divided by 4. And then for our second term here, using the same logic, we just have 12 divided by 6, which gives us 2 times x plus 3. And so right away, this question becomes much simpler than what we started with. It looks very similar to this question here, question 36. So what we're going to do is use our distributive property here. And we're going to distribute this 3 to both terms in our parentheses here, and this 2 to both terms in our parentheses. This leaves us with 3 times 3x, which is 9x, minus 3 times negative 1, or 3 times negative 1, which is minus 3, plus 2 times x, 2x, plus 2 times 3, which is 6. Now we can combine like terms and get x completely alone. So we have a 9x and 2x, and then minus 3 and plus 6 here. So we'll combine these guys. We have 9 x's, and then we added 2 more, so that gives us 11 x's. Then we have minus 3 plus 6. This will give us plus 3, and then we have 36 on the right-hand side. Now we want to get x completely alone. So we're going to subtract 3 on both sides and combine those like terms. We have 11x is equal to 36 minus 3, which gives us 33. And then lastly, to completely isolate x, we're going to divide by 11, since x is being multiplied by 11. Doing so, this gives us x is equal to 3. Alright, so that'll be it for this video and these practice problems.